In this video, I wanted to go over derivatives of inverse functions again, and just wanted to go over the three methods for finding derivatives of inverse function. So the first method is to find the inverse function first, then take the derivatives of the new y, and then plug in the given point. So over here, we actually have an x value for our inverse function, which is the y value for our original function that we're plugging in over here. So in this example, it says f of x is x to the third minus 1. Find g prime of 7. So again, this is our x value of our inverse function, which is the y value of our original function f. So we're going to first find the inverse function, and the inverse function, or the steps for doing that, is we replace our f of x with a y, then we switch the x and y. So every x becomes a y and every y becomes an x. So this is x is equal to y to the third power minus 1. Now we solve it for y by adding 1 to both sides and then taking the cube root. Okay, usually when we have our inverse functions at this point, we replace it with, and so we call this our g of x instead of y is equal to our cube root of x plus 1, because g is our inverse function for f. So next thing, we're going to find the derivative. So we could also write this as x plus 1 to the 1/3 power, which means that we're going to take the power rule. This is equal to 1/3 times x plus 1 to the power of negative 2/3, which can also be written as 1 divided by 3. And then we have the cube root of x plus 1 squared. Now we have to determine what to plug in. So since we are finding the g prime of 7, we clearly have to plug in 7 for x. But this is something you want to keep in mind when you're using method 1 and also when you're using method 2. You always want to plug in either the x value of the inverse, which is also equal to the y value of the original function f. So when we're plugging in 7 over here, we have 7 plus 1. That's 8. 8 squared. So we have 1/3 times the cube root of 8 squared. And the cube root of 8 is actually 2. 2 squared is equal to 4. So this is equal to 1/12. So we're going to skip over the second example, and we're going to jump, look at method 2 instead. Similar method over here. We are finding the inverse relation first. This one generally we use when it's a little harder to solve for the inverse function. And then we're going to differentiate both sides. We're going to solve for dy dx and then plug in as needed. So over here we have the function x cubed plus 2x plus y. We are asked to solve it at, or find the derivative of the inverse function when x is equal to 1. So remember, for method 1 and method 2, we either use the x value of the inverse function or the y value of the original function f. So these are the same. And therefore, in order to find the y value, we're going to plug in f of 1. So this is 1/3 to the third power plus 2 times 1 plus 1. So that's 1 plus 2 plus 1 is equal to 4. So really important, method 1 or 2, you use the x value of the inverse function, which is equal to the y value of the original function. You're going to see how this is different from method 3. So doing the same thing we did before. We're switching our x and y. So x is equal to y to the third power plus 2y plus 1. But we're using implicit differentiation. So the derivative of x is 1. The derivative of y to the third is 3y squared times y prime. And then the derivative of 2y is 2 times y prime. The derivative of 1 is just 0. So that's kind of where we are. Next step, we factor out the y prime. So we're left with 3y squared plus 2. And last step is we divide by 3y squared plus 2, and we end up with y prime is 1 divided by 3y squared plus 2. So in this step, we are plugging in our value for y. So we have y prime is equal to 1 divided by 3 times 4 squared plus 2. 4 squared is 16. 3 times 16 is 48. 48 plus 2 is 50. So our answer is 1 over 50. Again, what we had to do is plug in our x value of the inverse or y value of the original function. This time, since we had the x value of the original function given, we plugged that in order to get the y value. So method 3 is a little different because this is our shortcut. So we don't go through the extra step of switching x and y. And this is the reason why when we are finding the derivative and at the very end, we're actually plugging in our x value of the original function, which is the y value of the inverse function. So the process is a little different. But basically, by looking at the previous example, we could see down here that, or we may have noticed that the derivative of y is 1 divided by the derivative of our function and then plugging in a y instead. So this is where method 3 comes from, where we actually have a formula or a shortcut to do that. So what it says is the f inverse, the derivative of the inverse function of f is equal to 1 divided by f prime of f inverse of x. So remember, f inverse of x is actually equal to the original, so sending it back to the original x. This is why we plug in an x value at the end, not a y value, which is the y value of our inverse function. So that means we're going to have to plug in the -1. So in our example, we have x cubed plus 2x squared plus 1. We are trying to use the shortcut formula, so we know it's 1 divided by f prime, so that's the derivative of f. That's equal to 3x squared plus 4x, and then the last part is just 0. And finding the derivative of that, since we are plugging in our y value this time of the inverse function, which is our x value of the original function. You can see there's an x right here. We never swapped our variables, so it makes sense over here to plug in an x value of our function f. And that was given as the inverse value because 2 gets sent back to -1. So we have 1 divided by 3 times -1 squared plus 4 times -1. This is equal to 3 minus 4, which is -1/1 or -1.